Good morning, students. Today we will discuss defects in crystalline solids. Defects means irregularities or imperfections present in crystalline solids. The presence of these defects increases conductivity of the solid, so these defects are actually beneficial to us. Defects are mainly of two types. First, point defect, and second, line defect. In point defect, the imperfections or the irregularities is present in a particular point, whereas in line defect, the irregularities are present in the entire row. It means the entire row can be missing from the crystal lattice. Point defects are of three types: stoichiometric or intrinsic or thermodynamic defects, non-stoichiometric defects, and impurity defect. The first one, stoichiometric defect, actually do not disturb stoichiometry of the solid. Stoichiometry here means ratio of cations and anions. The formula of the compound remains same even after this defect. Second, non-stoichiometric defect. This defect disturbs the stoichiometry of the solid. The ratio of anion and cation can be disturbed after this defect. And the third one is impurity defect. This defect is due to presence of impurities in them. Now, stoichiometric defect and its types. In this class, we will mainly take stoichiometric defect. So, it is of four types: vacancy defect, interstitial defect, Schottky defect, and Frankel defect. So, now we will take these defects one by one. First, we will take is vacancy defect. It is the defect which is present due to vacant lattice sites. So, you can see here in the figure, there is a gap between the atoms. So, this is due to one molecule or one atom missing from the lattice. So, due to this vacancy defect, there is decrease in density of the solid. This defect can be developed by heating or it may be present naturally. Now, second type of stoichiometric defect is interstitial defect. Interstices word means the small gap present between the atoms. So, in this defect, small atom can occupy interstitial site. So, when some constituent particle occupy interstitial site, this defect arises. Now, due to this defect, density of the crystal increases because this is a foreign particle which comes from outside. So, overall density changes. It actually increases. Now, third type of defect is Schottky defect. This defect is important because question comes frequently on this topic. In Schottky defect, it is mainly present in ionic compounds where equal number of anions and cations are missing from the crystal lattice. Yes, you can see here the gaps. It is actually the vacant site of anion and cation. So, when equal number of cations and anions are missing from the lattice sites, this is Schottky defect and it results in decrease in density of the crystal. Now, where sizes of anion and cation are almost similar, this defect is well known. The best example is NaCl. Na plus and Cl minus, they are almost of similar sizes. Now, next type of stoichiometric defect is Frankel defect. Frankel defect is also known as dislocation defect or vacancy defect. It is actually present in those ionic compounds where size of cation and anion are, there is a large difference in size of cation and anion. So now you can see a cation which is usually smaller, it leaves its space and moves to another interstitial site. So due to this, there is no change in density because one cation changes its place from its position to the interstitial site. So the best example is AgCl and AgBr because there is a large difference between Ag plus and Cl minus. Now we will compare Schottky defect and Frankel defect because this is the most important topic of this concept. So in Schottky defect, equal number of cations and anions are missing from the lattice sites, whereas in Frankel defect, the ion, usually cation, it displaces from its position and occupies interstitial site. In Schottky defect, there is decrease in density, whereas in Frankel defect, there is no change in density. Schottky defect is found in mainly those compounds where cation and anion are of same size. In Frankel defect, the cation is usually smaller than the anion. So, example you can see, Schottky is NaCl and Frankel is AgCl and AgBr. So, differences is very important. And one more question which usually comes in exam, name the compound where both Schottky and Frankel defect found. So, the answer is AgBr, where both Schottky and Frankel defects are